Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Back for another preamp roundup, and we're going to compare the winner from our last roundup to this new little 4S preamp that I will link the website in the description. And I believe the guy's name's Matt. Sorry if I got that wrong, that designed this. He did an awesome job. And we are testing it with the Analog Discovery 2, both the output of the preamp and then the output on the speaker jacks of our little driverless test mule was what I'm calling it. It's a EL84 amp with no driver tube that needs about 14 to 16 volts peak to peak out of a preamp to drive this thing to full power. So it's a great test for preamps, using something that absolutely needs a preamp to drive it. And so last round, this little 6S and 7 direct coupled cathode follower guy with a fairly simple schematic that looks like this. And as you can see, not a lot of parts, pretty simple design. It is built with a printed circuit board, and the AC is going through the circuit board. It's got a little bit of a hum issue. We fixed some of it by twisting the wires going up here to this AC power switch across the side here. That helped probably get rid of half of it, and it's tolerable, but it's still there. But good sounding preamp with some nice 6S and 7 tubes, unlike these China ones, some Sylvanias or some various other ones. There's actually some made in China tubes that do sound good, just that these don't. So understand you're going to have to toss the preamp tubes that come in this amp if you buy one of these. I think this thing pre-built was less than 150 bucks shipped, and so, you know, quite a good deal. Didn't need to do any mods inside it to get it to win the challenge. So, hey, that's a bonus. And it came with a 120 volt transformer. So, no bucking transformer, you just plug it in and go. Here's our little contender for this round, which is the 4S preamp. It's got one driver tube. It's one triode in each channel. Here's the schematic. I don't think you could get much simpler than this. It's got a tube rectifier, which you could do solid state rectification if you wanted to. I know a lot of us like tube rectifiers just to be old school, so go either way. You can save a few bucks putting a couple of diodes in place of this. A little Hammond transformer, small chassis, very small footprint. This thing is dead silent. There's not even a hint of hum. And I'm going to praise myself for the wiring layout. Didn't need to put any kind of barrier between the power supply and the signal path or anything. It's just open underneath and absolutely no hum. So anyway, we're going to put both of these on the Analog Discovery 2, both on the output of the preamp and more importantly on the speaker jacks of this test dummy amplifier that we're using to test these preamps to see what we get going to our speakers, because as we all know, at the end of the day, that's what matters. So let's get to testing. First, we're going to look at this screen here, which is showing the THD versus frequency coming straight out of the preamp that was the winner in our last shootout. And as you can see, it's right at 0.5% all the way across the whole frequency response. It was a little higher than we had from the other preamps, but we determined in the last shootout that a little bit of distortion actually sounds better than those super clean ones did. So again, this being the winner of the last shootout, we're going to be comparing it to this other one. We also set the input level at 0.9 volts so that we're getting right here at 11 volts RMS on the output. And that's a way of leveling the playing field between different preamps when you're testing them for distortion. The other thing we're going to look at is the frequency response that we pulled out of this. And as you can see here, even down at 20 hertz, it's like a tenth of a dB. It's not even worth mentioning. This is, for all intents and purposes, a very flat frequency response. So the final test we're going to do in this segment is the THD versus power into the EL84 spud amp. So let's do a pull here and see what we get. And the output's tracking the input, which isn't distortion, but I've learned that when these two lines are basically parallel, that, or if this goes below this, that on this software it's performing well. And we can see here we got 2% distortion at 1 watt, and at 2 watts we got 3% distortion, and at 3 watts we're going over 4% distortion. But at 2 watts right here with 3% distortion, we need a half a volt RMS of input sensitivity. So next we're going to hook up the other preamp and see how it compares to this one. Okay, so now we've run the other little preamp, and this is using the 12AU7 with the cathode bypass capacitor. And at the same 10 volts RMS output with 0.9 RMS going in, we've got a lot more distortion showing on the output. It's showing almost 3% going into a 100K load. And I also tried it with a 50K load, and it didn't really seem to change anything. So I don't think it's related to the impedance being driven, just what this thing's putting out. So let's look at the frequency response. And there is a little more roll off here on the bottom end, but it's still not anything I would get. It's like a third of a dB, and it's showing a little bit of roll off on the top end where the other one was just flat across. But again, up to 10K it's perfectly flat, and it's got a tiny bit of roll off on the top end that I'm just not real concerned with that either. The interesting thing is, let's see how this thing drives the actual amplifier and what kind of distortion we get out on the speaker outputs of the amp being driven. So this was the previous preamp, and we had 3% distortion at 2 watts with a half a volt sensitivity. So let's run this one and see what this one does. Interestingly enough, at 2 watts on the output of the amplifier, we have less distortion, even though we measured more distortion coming out of the preamp. So clearly that number that's coming out of the preamp from at least this test doesn't equate to what you see at the speaker jacks. And this equals what I heard listening to this preamp is, to me, it sounds better. So at 2 watts we have less distortion at the same half a volt RMS input, and across the board we've got lower distortion, even though measuring at the 100K load on the output directly out of the preamp, we had 3% instead of 1%. So, guys, I honestly don't understand what's going on there. But I do know what really matters is the system. And what matters is what we're seeing at the outputs of the amplifier going into our speakers. And this little preamp delivers cleaner output to the speakers than the previous winner did. And like I said earlier, before I even tested anything, just listening to this preamp plugged into that little spud amp, it sounded better than the previous winner. And we're seeing that on this graph that's showing the distortion coming out of the amplifier going to the speakers. So last, I want to try a 12AX7 in this little preamp and see what kind of numbers we get out of it. And then I think I'm going to try disconnecting the cathode bypass capacitor, which will introduce some negative feedback in the preamp, and see if that makes it even cleaner. Okay, here's the new preamp with a 12AX7 in it, and as you can see, we get a very similar distortion, 2.5%, but this time we're running 0.25 RMS in to get our 11 volts out. So clearly this is making a ton more gain than either of the previous preamps did. And then when we look at our frequency response, we got the same pattern. It's rolling off on the bottom end. Looks like it's actually rolling off a little more on the top end than the other did, but up to 10K it's flat. And so this all looks good to me. This is very usable. But now we're going to do our THD versus power. And this is the power, again, coming out of the EL84 spud amp that's being driven by the preamp. And let's see what we get here. And 2 watts, we still have less distortion than we did with the winner of the previous preamp shootout, but it's only taking 0.1. Let's go on the other side of this. There we go. It's 2.7% distortion at 2 watts out, but it's only taking 0.116 volts RMS to drive it to that. So it has 5 times more gain with this 12AX7, and it still has less distortion than it did with the winner of the previous shootout. And I saw the same thing when I had this hooked up, that it really has too much gain with this 12AX7 with my DAC. It goes into distortion at probably a quarter volume, and so the use that I have out of this preamp doesn't need this much gain, but you possibly could have a really weak source where you need this much gain, and that's the beauty of this little simple preamp. Because it doesn't have a cathode follower, you can just swap in different tubes to get different gain amounts to fit your needs out of a preamp. So the next thing I want to do is unsolder the cathode bypass cap and run these 2 tests again and see what, if any, difference we get out of this little preamp. Okay, so here is the newer preamp, the little single tube guy with a 12AX7 and no cathode bypass cap. And as you can see, we've lost some gain. We had to put 0.65 RMS in to get our 11 volts out. But we've also got 1/3 the distortion. We're down at 1% across the board. So the negative feedback that's coming through the unbypassed cathode resistor is helping to lower the distortion. And this is coming straight out of the preamp into a 100K load. And similarly, when you look at the frequency response, we've picked up some low-end frequency response, and it's basically flat from 10 hertz up to 10K. And it rolls off on the top end just like it did before. Not too concerned about that because there's not a whole lot of music up in that range anyway. I know you've heard me say that before, but at least for me, this range really doesn't mean a whole lot. And we're still only down like 1.5 dB at 20K, so that's totally acceptable. But now I want to see if the lowered distortion coming out of the preamp equals lower distortion coming out of the power amp. And while it's taking twice as much input voltage, we're seeing higher distortion at the output jacks of the amplifier than we did with the bypass cap in place on the cathode of the tube. Like I said, guys, some of this isn't making a lot of sense to me. That when we're testing the distortion coming out of the preamp, it's lower, but then when we look at the output of the amplifier, it's higher. So what that's telling me is you can't go by measuring the distortion out of the preamp itself, because it doesn't equate to what you're seeing at the speaker jacks. And what we really care about is the distortion at the speaker jack. So we pretty much just need to be testing it there, because that's what we're going to be hearing. So the last test I want to do is with the 12AU7 with this cathode unbypassed. Okay, so here is our little single tube amp with a 12AU7 with no bypass capacitor installed. And again, we lost some gain. We had to go up to 1.3 volts to get 11 out over here. And we did drop from 3 to 2.1% distortion. And that's directly out of the preamp into a 100K load. We go over to our frequency response, and we picked up a little bit of low frequency response, and the high end isn't rolling off quite as much as it did with the 12AX7. So that looks great. But now let's see what the THD versus power is coming out of this speaker jacks on the amp that this thing is driving. And this was the 12AX7 unbypassed, and we see we have 3% distortion at 2 watts, and it took 0.26 volts RMS to drive it there. Let's see what this guy does. And 2 watts, we've got 2.5% distortion, and it needs 0.65 RMS to get us there. And less distortion, but I believe we had even less distortion with the cathode bypassed. And if I didn't say it earlier, we used some Audio Note super nice bypass cap. So that's not the problem of having low quality bypass caps. These are super nice ones. But again, it looks like that the lower distortion from the output of the preamp doesn't equal lower distortion on the speaker jacks. And that's why I tell people you've got to test this stuff. You can't assume things that, oh, it's less distortion coming out of the preamp, that's got to be better. But then you check it at the speaker jack and it's not better. And again, not an electrical engineer, not a scientist. All I know is I run tests and look at stuff and listen. And I do want to put a switch to switch this bypass cap in and out so I could A/B listen to it, because there may be some tonal changes that we're not seeing on this distortion meter that would sound better or worse. Don't know until I try it. So that's one of the next things I'm going to do, this little preamp, and then follow up with that. Let me get that done, and then we'll wrap up this video. So we're back from our testing and went to do some listening, and without further ado, the winner is the 4S preamp. Keep it simple, stupid. And I keep coming back, and this may turn into my mantra, is simple sounds better, or SSB for short. We'll have to make some little stickers that say that, but or something. Anyway, I swear every time I get involved with these kind of things, the more I'm finding out, the less complicated this stuff can be, the better it ends up sounding. I mean, a great example of that is on my A12 mods. I went from that paralleled 12AX7 to just a single triode. It's like, I don't care if it's just sitting there doing nothing. I'm not using it. We're going to run it as a single triode. And people are, oh, you shouldn't do that. You're paralleling them. You get lower halves the plate resistance, which is going to, it's like, it sounds better with a single triode. And the same thing when I was looking at these, when I was talking about building this amp with a single triode. Oh, you need a cathode follower. You need the plate resistance is going to be too high, and it's not going to be able to handle the load. It's going to create a distortion. And oh my God, you can't put the volume control on the output. That's just going to ruin it, because then you're going to have an impedance mismatch between the preamp and the amplifier. Guys, I don't know what's going on, but this amp combo makes less distortion than this one does coming out of the speaker jacks. Now, coming out of the preamp, there's more distortion in this one than this one. But when you hook these up to a load and are actually driving an amplifier, what comes out of the speaker jacks is cleaner with the simpler preamp. And like I've told y'all dozens of times, I'm not an electrical engineer. I don't dive that deep into this stuff, too deep into the theory and spice models and all of that stuff. I just know that when you hook this simple triode preamp up to this amp that needs a preamp, what comes out of the speaker jacks is cleaner. And at the end of the day, that's all that matters. And this time I listened to this preamp, and I listened to this preamp before I hooked any test equipment up to it. And this one sounded better. I knew this one was going to win on the numbers that came out. And I was a little shocked when I saw the distortion numbers on the output jacks of this into a 100K load were higher than what I was seeing in this. But running it through this, it's cleaner. So at the end of the day, what really matters is, what does it sound like? The other thing that was interesting is seeing the difference with having the cathode bypass capacitor in the circuit and not. So I put a little switch on here, like somebody commented in the forum that they did, and they were trying to describe what it sounds like. What it sounds like to me is at the lower volume levels with the capacitor engaged in the circuit, that it's crisper and it's got more punch. But as you turn the volume up, 5/8, 3/4, start really pushing the preamp, it gets a little distorted. You flip the capacitor in and that distortion goes away, and you can turn it all the way up. So having this capacitor being switchable as an option is a worthwhile thing. The other thing somebody noted was that when I built mine, there's no ground lift switch. And people are saying, oh, you're going to need that. No, I don't. And I'm still baffled why people have so many problems with ground loops and ground hum and noise from that, when all of my gear is chassis earth safety grounded. The first point in the power supply is hooked to the chassis, and all the signal path is star grounded to that point. And daisy chaining this stuff together, I have no ground loops. I got phono stage, preamp, amp, all grounded separately. They're all plugged into the same power strip, but they've all got RCA connectors going between all of them, and there's no hum. So, guys, I don't know what y'all are doing that are creating these ground loops. I don't feel it's safe to have tube gear with the ground lifted, because you've got hundreds of volts in these tubes, and the ground circuit has that potential on it. And if it's not safety grounded, if there is a problem or a short, it's not going to blow the fuse until it starts melting transformers and stuff. And so I don't know what's going on with you guys that are having these ground problems, but I'm not having them, and I have to attribute it to that all my gear is built the same way, and it's all grounded the same way. And maybe if I was grounding one unit at the the power supply, and then I was grounded in another unit at the input jacks, that maybe that's what people are doing that are causing these problems. I don't know, but anyway. So I think we're done with preamps for a while. Ready to get into the 47 amp. If you've never built a tube project before, this little 4S amp is awesome. Again, link in the description to the website that explains more about it. He's got charts with all the gains, stuff like that. For most people, a 12AU7 is going to be plenty of gain. It's as much gain as this has. It's twice the gain of the other preamps that we had in the other Shootout with one tube. So I don't know why those other preamps had 4 tubes and had less gain and didn't sound as good as this little guy does. So I guess, end of the day, keep it simple, guys. You don't need these super complicated circuits to get good sounding audio. So anyway, I hope you're enjoying my channel. If you are, please subscribe, please like the video, and we'll see you soon for more tube audio fun. Have a great day.